Hello and welcome back to Blackbird. This is a combined lecture for operators as well as for arrays in Java. So it's going to be long, and so buckle up for this entire video. You're going to learn a lot of new things if you're a beginner, and you're going to improvise on a lot of things on the fundamental side if you are a working professional. So let's begin with the video without any delay. On this topic of operators and something new, I just want to discuss a few things without proceeding forward because we'll obviously discuss about operators in the next section after this video. So I won't dive into real depths of operators and all. I'll just get it down straight to the point with the minimal knowledge that you would require to start off creating your Java applications and performing some mathematical stuff around it. So look, there are a lot of type of operators, okay? But the most basic ones are the arithmetic types. You might also need relational and logical operators. So in the arithmetic, we have simple operators like plus, minus, then multiply, divide, modulo. In the relational, we have greater than, less than, greater than equals, less than equals, and double equals. And in the logical section, we have, well, and, which means an and, or, and not. So these are the operators that you'll need to get going in order to create your first Java program and make it a little bit mathematical. Apart from this, there is one point. Whatever you use with these operators, okay, let's say there is something and then I need to multiply and then there is some other variable. These particular variables are called operands. Okay. Now, be it a multiply sign or be it a divide sign or be it a modulo sign, or there is any kind of a relational boolean condition where you need to check if x is greater than equals y, there you can use relational operators, or like x is equals y, there you can use relational operators. Chaining of these operators, two relational expressions, is done by a logical expression. You can really have a and condition here, or you can also replace it with an or, but chaining is done by these logical operators. This exclamation mark this exclamation mark can also be used to reverse or to negate the boolean logic. So let's say if I write not true, which it'll mean false simply, and if I write not false, it means true. So it can be also be used for relational expressions where you have conditions, and you want to check for exclusive of those conditions, and then there you can negate the relation totally and then um, get the output as expected. Now when you perform some operations, you need to store them into variables. So let's say if I'm performing some arithmetic operation, I can if I'm performing division, I'll use double div is equals a by b, as simple as that, because it's a division. So I want the division result of a divided by b, where a is the quotient and b is the divisor, where a is the dividend and b is the divisor, I'm sorry. Now let's say if I want a sum of two numbers, I would say n sum is equals a plus b. Now it is also possible that you can chain in these operators into an expression, that is what we call a Java expression, mathematical expression. So I can really write int multiply is equals, and within braces I'll write a plus b plus c and times d. So I can do this as well. We make use of these round braces in order to denote that this particular thing has to be executed first, and then the result has to be multiplied to this value which is stored in the variable d, and then at the end we should assign the resultant value into this variable multiply. All right, now let's talk about something new, entirely different from what operators are. Now, this is really important. Why? Because um, I cannot move forward with these lectures without explaining you this stuff. So, what is it? We'll talk about the new keyword. Where is it used? It's used to instantiate objects. It's used to instantiate objects. It's used in the creation of objects. It can be used to instantiate any object, or you should say a class or any reference data type. In the starting lectures we had talked about primitive and reference data types. The latter one, the reference data types, which are like the primitive types, there are eight primitive types: byte, short, int, long, float, double, boolean, and char. Apart from all of that, everything is a reference type in a Java. So all those reference types can be instantiated with the help of this new keyword. How exactly do we do that? Let's say I have a class person, okay, and I have something within it. I have another class which is a public class driver, and within the main method, what I'm doing is I'm just writing a raw code. In the main method, I want to instantiate and create an object for this person class. So what I'll do is I'll simply write person p is equals new person, and this is the syntax for creation of objects with the help of new keyboard. There is one and only way you can create objects, and that too for concrete classes. You can use this method to create objects. Okay. Now, there is one different thing that I must say. If you are using a singleton class, you have to instantiate using a factory method. Now, these are all design principles, so we'll talk about this in some later course. But this is something important. In order to access the member methods and variables, the instance variables, you need to instantiate the class. You need to have an instance of this class. So here, this variable p is the instance of the class person. Okay, and how this will look in the heap memory, let me show. So this is, let's say, this is the heap memory, and within this we have a object. P is the variable which is storing the address to this object. Okay, it's storing the memory location of this particular object on heap, and this is a person type object. All right, it has its own variables and methods within it. So with the help of p, I can tell the compiler that what variable we need to access, and from what part of the heap memory we need to access that variable or method. Okay, that is what And that is why we instantiate classes in Java. There is another exception where you cannot instantiate things apart from a singleton class, which is interfaces and abstract classes. Okay. Now, these are two special things that again we'll be discussing in the latter part of the course, but just to provide an overview, I can tell you that you can only instantiate and create objects for concrete classes which are completely implemented in Java. You cannot instantiate or you cannot create an object for a class which has abstract methods, which means that methods which have to be implemented by the um, subclasses, or you cannot create objects for interfaces which just define what type of behavior a class should have. Okay. So I'll just give a small and a brief example for this if you did not understand in case. Okay, I'll be taking an example for this one. Let's say humans is an interface. Within humans, you have male, which is an abstract class. Then here we have, let's say it's me, let's say it's Venkat. This is the concrete class. This is the abstract class, and this is an interface. You can only instantiate for concrete classes. You cannot instantiate abstract class or interfaces because these are partially implemented. This is fully implemented. If you try to objectify me, I'll definitely sue you, but um, don't try that. I just mean with an example, but that's okay. So yeah, that's the entire story about operators and instantiating classes in Java. Let us have a practical demo before we jump on to the user input section. Okay, so what I'll do is I'll just create a package. Let's say, or let me just create a class itself. Um, Instances dot instance example. Okay, so what I'll do is I'll again enter the presentation mode. Right. Now, this is a public class, okay? All the things that I'll be doing here would be the instantiation of objects will be doing here. So let's have a main method here, and we'll have a separate class. Let's say class person, right? What does a person have? Person has a name, person has an age, and person also has, let's say, some behavioral things like public void eat. Oh, it cannot be an abstract method. And within this eat, let's say the person is eating. Within this sleep, let's say that the person is sleeping. Okay. So since I'm a programmer, so I only need to eat and sleep. I don't know to code, how to code, but it's okay. I'm learning day by day, just like you guys. So now, if you see, eat, sleep, the age and the name, All of this belongs to the class person. Now, in order to access all of these, what I need to do is, and I need to instantiate them. I need to create an object for that. So I'll say in this way. So I just replace this with person.eat, and let's see what it does. If I shift an F10, oh, it's a type inferencing example, I suppose. I'll run this. Look, the person is eating. Now, if I directly say that, I need to access the eat method, just like that, I cannot do that because it cannot resolve the eat method within the class instance example, because exactly we don't have any eat method within this entire class. We have it in this class person. And in order to tell the compiler that, you need to access this eat method from the person class, we need to access it in this way. This is the dot operator that I forgot talking about. It is used to reference to the members of a particular object. Okay. Now, if I say person dot sleep, well, the person is sleeping. There is one error. No, not an error, but a logical error, kind of, with this entire class, and it's that we don't have a constructor which would accept the name of the person and the age of the person. Once we have that, we can simply say this dot name is name and this dot age is age. Now, what should I do? Creating a person object, but that person cannot be a nameless person, or it cannot be an ageless person. So I need to specify the name and age of that person. So I'll write name is Venkat, and the age being an integer, I'll write 18. Okay. So now, if I want to access the name and age of a person, what I should do is I'll just create a getter and setter, okay, which would return this dot name, and similarly for public int get age, return this dot age. Done. Now what I can do is I can simply write system.out.println person is, and then I'll write person dot get name, and then I can append it with, and age is person dot get age. Oh, it's age, right? Now if I execute this code, let's see what happens. Okay, look. First we are calling the eat method. So what we got was the person is eating, right? Then we got to know about the sleeping method, and then we invoked that the person is sleeping. And since we had this in our constructor parameters, Venkat and its age 18, and then when we are printing this here in this line, it returns the person is Venkat and his age is 18. That's how you go about accessing the data members and member methods of a class. You remember me talking about encapsulation? Well, these methods and these variables are members to this person class. These are its data members and member methods. They are encapsulated within this one unit, and then that unit is or can be accessed by the person class. Now, what is a constructor? Constructor, simply speaking, is something which would give the default, which would give a initial value to this variable name and age. It basically is like a method only, a special kind of method which does not return anything. and which is called during the instantiation of a object, which is used to initialize the data members of the class. These name and age variables are data members, class variables for this person class. And that's it for operators and something new. Let's move on to the next lecture. Now let us talk about dealing with user input in Java. Dealing with user input involves two classes. One is the scanner class and the other is the buffered reader. Now, definitely, since I am the instructor for this tutorial, I'll choose to go along with scanner first and then talking about buffered reader after we complete file handling. So, scanner also belongs to the file IO part of Java. It's present in the utility package, which is java.util. Okay, and its qualified name is java.util.scanner. So, in order to use this scanner class, there are some steps that you need to follow. Firstly, import this scanner class, and then here you need to specify the qualified name that I just wrote above. Okay, don't forget the semicolon at the end, it's an executable statement. Then you need to create an object of scanner class in order to access its methods. And thirdly, at the end, you are ready to use all the methods that scanner class provides. Developers seem to use scanner class just for command line inputs. But professional developers actually know about a lot of applications that scanner class provides. There is a class named as console. Okay, it has some methods, and the scanner class is basically a wrapper of this class. Why? Because scanner class implements the console class. I mean, it implements a lot of features of the console class, and it creates a very sleek and modern way for the programmers to interact with the users of their program. Okay, scanner has some methods that we need to know, like to in order to accept a int type data, we can really say next int. Then we have next double, we have next long, and so on and so forth. We also have a character input for scanner class. So in order to have a character input, what we can say is um, we have to first accept a word, and from that word we'll just say the compiler that I just want the character at the 0th index. Okay, it's like at the very first index, and this next dot char at 0 should be preceded with the instance name of the scanner class. In order to accept a string sentence, you can use next line, and in order to accept just a single word from the user, you can use the next method. Now let us see a practical example of using scanner class in Java. So I'll go to IntelliJ. I already have a class named scanner input. Okay. Now if we closely look in the scanner class, we are going to see all these methods like next long, then we have here next int, and so on and so forth. So what we do is follow the first step, which is importing the scanner class, which is present in the utility package, which is again present in the Java package. After that, we are going to instantiate the scanner class and specify input stream, which is system.in. Now this system.in can be considered as a console input for now on, but it's good to know that system.in is an input stream which connects, which is ready to use and which connects the console to the scanner class so that it can really interact with the objects. This being said, I'll go on to make my program interactive by saying enter any name, and I'll store that in this variable, let's say sc.next line, because I want a qualified name. Then let's say I want the age, then I'll say int age is sc.next int, and then I'll display the name and age. Okay, name is, and then plus name plus, and age is, then plus age. Now let us run this program and see what the output would be. Simple, it's asking for my name, I'll write Venkat, and my age, I suppose it's 18, legally clear. So the name is Venkat and age is 18. So, yeah, I mean, I can also write a if condition here, like if age is greater than equals 18, legally clear for driving license. Okay, so if I just execute this for fun and I re-input the values, it shows my name and age and that I'm legally clear for applying for a driving license. Obviously, you all know that I won't be applying for a driving license if I'm talking about something as legally clear, but it's okay. Let's keep that between me and you. This is about user input in Java. Now, there are more compact ways in which you can go about taking user inputs in different, you know, variables, and I'll show you some of the char data type. So in this case, what I'll write, since I have the object name as sc, so I'll write sc.next, which accepts me a word, and then I'll say the compiler that I want the character present at the index 0, and then I'll definitely print this to the console. So let's say um, I enter a character capital A, and the output obviously is capital A. But let's say I enter the name Venkat, so I'll get a capital V printed because um, I am allowed to give a word without any white spaces. But what the statement here says, it is going to store the character present at index 0, which is capital V, and it prints it to the console. That's it for user input in Java. About the buffered reader, its learning curve is a slope, like it's a steep hill. Okay, so we won't be discussing it right now. We would be discussing it when we having a discussion on file handling. Okay, and at that point of time, we'll discuss this buffered reader. Now, there is one more thing that I can ask you to try out, which is all of these numeric methods: next long, next float, next double, then next byte, next short. can have a user input. Okay, they accept a user input for you, but they also have a parameter. They can also have a parameter. That parameter is the radix. So in the very first video I talked about the radix, what is a radix in hexadecimal, octal, binary and decimal systems. So for like a binary system, the radix is 2 for binary, then it's 8 for octal, it's 16 for hexadecimal, and it's 10 for decimal. So 10 for decimal is used as the default radix for nextant if it is not specified. But if you want to use another radix of your choice, you can also use that. And that's it for this video. In the next video we'll be talking about arrays in Java. Till then, keep watching and keep learning. Thank you.